So you can choose. So at this point, I'd like to invite the panel members up and some that we haven't heard from. Justin, you want to come up and just say a few words about yourself? Mr. Bonnie, and Ian is coming. So just go ahead and have a seat. Go ahead and grab the mic. Say who you are.
Hi, I'm Justin Stottlemyre. I'm currently the Distinguished Engineer and Director for Storage and Compute for Intuit. Formerly, I was at eBay, PayPal, Facebook, and Shutterfly designing large-scale systems. Currently, I'm in the middle of designing a lot of different things for Intuit, as well as helping them transfer from a traditional data platform inside of their own data center to AWS, which involves a lot of S3 style semantics. Also working a lot of big data components with Hadoop as a big data lake, transitioning from a lot of Vertica and traditional big data applications. So making that move today is pretty complex. And so we're also using object store at scale for backup, archive, and replacement of S3 internally. So I'm happy to talk about any and all of those components, and I think I'll have to go grab myself a seat.
Oh, did we run off?
I'll take one from the back. I promise not to trip.
Okay, so we've covered a lot of ground in some of that, and we've talked a lot about object stores and other types of stores in the last day and a half. So I invite anyone to come up. If you have a question, come up to the microphone. I did write down a few leading questions if people would like to start with that. So this is one. For those of you that have made the transition to have an object native, and Justin, this might go to you, what was the first step in getting developers to understand and change their ways so that they could use it natively? Great, Mark.
There we go. Figured I'd test that out first. Ops guy. So it ends up that it's getting easier and easier to make that transition in a lot of cases because almost every startup and small company I'm talking to today is aware of AWS and S3. So while at scale it's much easier in the HPC sort of world, it's easier to deploy and roll your own and much more cost effective. I like to tell folks that, if you're deploying a gigabyte of storage, it's much easier to do it in an Amazon sort of world. But if you have to come talk to a couple petabytes, come back and talk to me because I have to spin up a computer, a disk. Amazon's 5 cents a gig a month for that 1 gig. And it makes it really easy to deploy at 1 gig. But do the math, and after a couple of petabytes or dozen of petabytes or exabytes, and all of a sudden you're making them one of the most profitable companies in that market in the world. Engineers actually understand it, even when you start to explain just the economics to them like that. And so that actually helps a lot because everyone does tend to be a little bit cost conscious at most of these companies I've worked with, and they're very familiar with S3 style semantics. I'm currently in the middle of actually working through from Gluster to S3 style conversion. There was a couple of things that came into play there for us. One was showing them the performance benefit of actually switching to an object store versus Gluster. Second one was actually the economics, and the third one was the reliability, which actually goes up with an object store versus a traditional Gluster model. So all of those things coming into play sort of give me a Venn diagram of how to attack the sales model of selling that internally to engineering teams.
Thank you. Anyone else? You have a question?
So the panel is about object storage semantics. I have a question about APIs. No one this week, with the exception of the tutorial on Monday, has talked about Swift. Is the protocol debate over? Is S3 the victor there?
Yes. So no, actually, when I talk to a bunch of different folks, I still get a lot of questions about Swift as well. There's a lot of baseline components that are kind of similar from the RESTful interface, but everyone I talk to is building S3 first, Swift second.
To that, though, IBM is doing a lot of work with OpenStack and coupling OpenStack Swift with GPFS, and that's something we're just beginning to look into. So I don't think it's dead yet.
If you want some horror stories about that, come talk to me.
All right, okay. Thank you.
Okay, how about a POSIX question? Does NFS have a life after version 4? Are there people working on the next generation, or is that pretty much it?
We have a lot of customers still using NFS. I mean, I don't think it's dead at all. No.
Are there further improvements to be made, or is it good enough?
I have not heard, PNFS was really exciting, but I think it's gone. But NFS v4, very widely used.
So, as mentioned, PNFS was very exciting, but it's kind of failed to materialize. With the advent of some newer technologies, RDMA, converged Ethernet, and other styles of clustered file systems, NFS, while not going away anytime soon, could turn into more of a legacy-based protocol for sharing. So it's difficult to see where some of the future components may lie. Some of the security features of NFS actually make it inherently more security-minded, I guess, than some of the other competing products that are out there or other competing protocols. So I think that can help it keep a leg up for quite some time.
Yeah, I'd say I don't think that any of our NFS use is going to go away. If NFS over RDMA was revamped, that'd be handy. But, all protocols get to a point where we don't need to work on them. I don't know anyone still developing the FTP protocol, but it's still out there.
For end user shares, which I don't know how much fit into your organizations, but I'll ask, are any of your orgs using a sync and share type of a product, like an internal box or Dropbox or any of those types of items? I'm wondering if there may be a new protocol that can get around some of the limitations.
So previously I've looked at using things like Panzura and Nisuni as gateways for some of the big back-end object stores, and they're useful. Currently though, Intuit is actually using Box and Google and a few other components as well as AWS pieces. So it seems to me that it really depends on kind of the security components of what you're using there. I think that there's still a pretty ripe space for people to develop and for companies to make money there. Yeah.
How about the world of security? Are there any pros or cons in the world of object storage to be discussed in the world of security? Is it too lacking or too cumbersome?
Well, I can say from the perspective of, from the MARFS thing, we punted on trying to do object security. We ended up using the POSIX and the GNU standard view just because it's easier than trying to figure out how to do it on object.
So for us, we're actually starting to take statistically 40% of your taxes and tax information is inside of my company today. And within 2 years, a chunk of that would actually roll out of our internal software, internal storage, and out to AWS. So having that set up in sort of using the S3 style of security is actually highly beneficial. There's a lot of components to there with the keys, the encryption, all being in the hands of, a lot of times being in the hands of the user and being able to re-encrypt that data as needed, as well as set up smaller blast radius for data breaches. It's really important and it's very useful. And not many other components actually do it the same way as you can in sort of an object store.
Yeah, so one of the things that I want to be able to do in the near future is intentional data loss. So having objects that are fully encrypted and that we can intentionally lose would be a really handy thing.
So like via key destruction instead of having to wipe the file. Just to
Yeah,
key.
absolutely. Lose the key, lose the data. So there's workloads that we would be able to float. They're high security workloads. We'd be able to float them onto the cloud for the 5 or 10 minutes that they need to exist, rather than run, $100 million global networks with key changes and security and all of the rest of the overheads. We could actually justify doing this and protect the data adequately if after that 5 to 10 minutes we lose intentionally everything.
Matt's got a question.
So one of the things when Gary and I were talking about kind of putting this panel together and talking to Randy about it, one of the things that we kind of observed, it seemed like the object semantics were sort of evolving over time. So pure objects, which is no in-place updates, sort of limited scale namespaces, et cetera, that allowed the cloud providers to really, provide massive scale. So they kind of simplified the semantics, and then that helped them solve the scale problem. But since then, it seems like they've kind of incrementally started add back semantics. So sort of maybe two questions. So the base question is maybe for Justin and Ian, both who have deployed some really large scale objects. Are the object semantics good enough? Is there something that's seriously missing? Would you change them much, or you just don't think about it? They're good enough. You layer service above it when in whatever limitations you might have in the object storage. You layer a service above it. Problem solved. Is that kind of how you think about it?
I guess I'll quote Michael de Klerk from last year. We've been working with objects for a long time. POSIX is just the semantics that interfaces to an object store. It might not be as flexible as the new ones that we have today, but essentially we've been doing that. And I think the functionality exists within POSIX and within that underlying file system layer for a reason. And I think object stores have a new reason to exist, but over time you may see some of that functionality converge. I mean, what we're trying to do is just present the object storage within the context of the workflow. I mean, whether you've got an ext4 file system, an object store, and then a Hadoop repository, as long as the user can move their data and access it in place, then we've achieved our objectives. And then that, I guess, makes it easier for adoption over time.
I agree with that pretty much completely.
Okay.
Access to the data is what it's really users always want, right? Just like somebody mentioned earlier today, you want to be able to get the data on your cell phone. You don't really care how it's there. Yeah. And actually, I was really interested in the Mars presentation earlier. So it's a much different way of thinking about how people deploy an object today, and it's just not something I'd really ran across before. So it was very interesting to see. And in the meantime, you're still seeing, as mentioned, all of these gateway products that are sort of bridging both the traditional and legacy applications into sort of the next generation object style world. So when you're operating within the context of an object, it's just a much simpler style of operating. And as you called out, everything else that we're doing is really just a layer on top of that.
So it's almost like, say you have a block device and you can layer a database or a file system or whatever. So you create that. Okay, very good. So then maybe the question for the other panels, so it's there that you're doing POSIX directly on objects. So we kind of...
We're using the libs3, so it's very easy, standard for us to talk S3 protocol.
Sure.
Get put.
So I guess my question is, so David, you and Gary made a set of choices in your team about, okay, well, this is what we won't do for POSIX, and then Carrie's probably got another set. Are we at a point where maybe people can agree that maybe we need a new, maybe it's not a standard, but just like an agreement, here's what we would like to, here's it close enough to what we need, or is it okay just to have a header, it's another service, if just write another service and we can develop as we wish. Maybe that's the key, is just you present what you need. And yeah,
I know that the Mars Best.
I don't know if that's on, Harriet. We're having trouble hearing you. You got to get it really close because you have a soft voice, actually.
Is that better? So we did not relax POSIX. We are still a POSIX file system. We are archiving out. It's just another copy, right, to the object based on the policy. I know the Mars FS did relax the POSIX, so, but that's a choice. And certainly I would like to because there are some advantages to relaxing, and possibly that's an option later for us. But right now we are still POSIX.
Yeah, the big win for us was that we didn't want to have to deal with all the edge cases that happen when you're trying to support update in place on something that's so big. Because we have these big file sets, and if you have a petabyte-sized object and say you've pushed it out, or petabyte-sized file, sorry, push it out to a bunch of objects, how do you handle, you seeked over here, you wrote that thing, are you done? Are you going to seek to the next one? Do we have to pull back that object? We stage the whole thing back on disk, and it's easier just to not do it and then enforce and make it simple. And the simpler you make it, the cheaper and easier it is to make a big storage system that scales well.
Okay. Do you have a question over there?
Yeah, I guess object storage is kind of taking over the world. But it looks like it's still, from what I've heard so far, it doesn't look like anybody uses it for like primary HPC storage. But what would it take to get there?
So we do actually have our own object or collection, if you like, model. And we've had that for about 4 years. And it's directly tied into the HPC facility for the purpose of reprocessing. Right? So it's not as flexible as, say, S3, but it does perform an object function, and we do directly process against it.
From my perspective, it's more that the legacy apps that we have can't be adapted in a short period of time. So if we had new apps that we're designing, sure, they might end up actually talking to objects or something like that. But anybody that has legacy products or software, they can't adapt. That's probably why that's the tail.
So we need to crowdsource a Fortran S3 API.
I hope not.
Let's get on that.
So there's another issue there too. Remember, people have been exposed to POSIX file systems now for 40 years, and they're still not doing that right. You know, don't put too much pressure on the object guys to, you know, change the world overnight.
Well, and certainly the scalability is the big claim of the object store vendors is like, yeah, we can do billions of files and it's a flat namespace and none of these pesky subdirectories to worry about. So my question about the gateways, if you have experience with the gateways, I mean, do they kind of just work are they cute when they're young, but they get really ugly as they get older? Like, I won't say cats, but.
Kind of depends. They also have the same, most of them are ingesting data via NFS and NAS. So they still have the same NFS limitations of, you know, so many files per directory and other components that you run into, and then they're just doing generally speaking, doing an intelligent hybrid model similar to what her company does, where they do local caching and build up files and then dump 32 meg objects out to either another object store or another style of storage. So they're basically tarring things up and shipping them out. So then it just becomes an exercise in metadata management inside of there, how fast and how long they can scale those things. So I found that it's really not a function of age so much as a function of number of objects that you're trying to abstract out.
The packing I thought was interesting in the MARFS, the pack file type. How common is that to be used? Is that used a lot in your world?
I don't know if it's common. So our large archive systems have built-in utilities to handle, so HPSS, there's a tar utility, because you don't want to beat up the storage with handling all these million little things. You'd much rather them be a collective thing for data, and then for metadata, view them as if they are not that, which is what we're trying to emulate, essentially.
Remember, gotta love the microphone. Get it nice.
Sorry.
There you go.
So following up on the object interface for HPC applications, so we have a lot of HPC applications, right, that are legacy codes that use the POSIX interface. And so I understand why from building a system, you'd want an object storage environment. It's more scalable. You have easier to scale the metadata requirements. But is there anything I could tell an individual application developer for why they would want to change their interface? I mean, I may have to tell them, well, someday you're going to have to do it, and that's life. Your processors aren't getting any faster either. But is there any hook right now that you would say, yes, your application would need to go faster, or is what explanation could we give them?
But that was the thing I was mentioning earlier when he had asked that question, which was really I used the arguments of simplicity and economics are usually the biggest two, as well as typically performance.
So what? Well, yeah, the HPC folks don't.
I
care
know
that much
it's a little
about the
different.
economics,
HPC
but
is different.
What do you
but
mean by the
You mean they don't care about economics?
They don't really, not the end users. But what do you mean in terms of performance? What will they see that's better than?
You know, these guys were
big
pushing
Lustre
28
file system?
gigabytes a second. I know that's not the end-all be-all, but that's not too bad. So it really depends on, you know, everybody's use case is different in what you think is fast.
Right.
Object stores tend to scale out wider and broader than almost anything else for driving levels of performance that are almost not heard of in any other application.
Right.
So just as an example for that, if they are going to look at cloud, for instance, for doing their work, and it's a high throughput type application, one of the things you could do, for instance, on Amazon is once they've switched over to using object, they could spin up 30,000 concurrent jobs, right? Each one talking to a separate object, which if you were doing that on a file system might actually get rather difficult. And so they could divide up their work. They could be done in 2 hours rather than, you know, having many more serial jobs. And so again, there is an effort to switch over to it. In some cases, it may just be ingest the file at the beginning and then do all your work, right? So the change for many people might just be, you know, one additional step of bring the file in from the object store, persist in local storage, and then go to town.
Yeah. So, I mean, typically we want to offer people an order of magnitude improvement if they're going to have to change all these legacy codes. So, you know, it could be we're just not there yet, but I've been looking for a couple of our users to try to give them a carrot or something to make them want to try it.
I have the exact same problem.
Yeah.
I'm step out of moderator like Tim did for a minute. But we have the same problem. We can explain till we're, you know, blue in the face about the economics to our particular set of developers. They're only interested in meeting their business users' next feature that's due, you know, 6 weeks from now. And sometimes taking a big step back for a huge improvement, it needs top-down leadership, it needs push, it needs a little bit of authoritarianism,
Right.
for lack of a better word. So that's why we've been interested in things like gateways to see if we can bridge the gap and such, but haven't found the
So I think just one parting thought on that was if you look at their workflow and can you reduce their workflow by an order of magnitude in runtime, then that would be a carrot. But you've actually got to have a look at the workflow, and that's what we've had to do all the way through. Yeah, we can't just hand stuff to them. They just look at it and go, oh, so gone.
One last thing is the performance aspect. The 28 gigabytes per second that we get out of our object store pales in comparison to any big parallel file system we can build that runs these workloads. I don't know how the cloud solutions now and object stores are not built to scale to the absolute limits of the hardware as it sits now. And it seems like there isn't anyone that's tackled that yet. So as a performance play, I don't think you can do it yet. We don't get 100% efficiency out of our object stores. We're lucky to get very small fractions of that. So it makes it easy to scale, but it doesn't necessarily mean that the scaling blocks are very big.
So my question was, listening to all your talks, and Ian, I apologize if you are using an open source object store, but the commonality between all of you is you're using a commercial object store. So as we look at open source efforts like Ceph, React, I guess, how do you see the viability of growing to very large scale with those projects in the future, where it stands now, and so on?
So I think we use a lot of public cloud object storage. We've probably got a few little ones that people are playing with internally, but once that becomes big enough, we'd consume a commercial product. I don't think that we would ever muck around with the amount of data that we've got. We just don't have the resources to learn a technology.
Sure.
So we are using a commercial object store, and when I was at Shutterfly deploying over 100 petabytes there, you know, certain portions of scale mean different things to different people. So for you, how big is your scale, and what are you thinking of?
Hundreds of petabytes up to an exabyte.
Or so if you think about the amount of people that have deployed that amount of data, you know, probably half of them are in this room. And there's only a couple of companies that actually, there's only a handful of companies and government entities that really deployed at that scale. And they're almost using all similar or along the same lines of products. So if you start to look at a React or, you know, I don't know anyone that's deployed it that large. When I think about Ceph, you know, I've talked to people that have actually hit the limits of their scale, and they're at a fraction of the numbers that you're talking about, right? Not even just double-digit petabytes, right? That's it. And so when you start to look at people that have actually already gone to hundreds of petabytes or exabyte, there's just not that many solutions out there, right? AWS clearly does it. I've done it with CleverSafe. Other people have done it, I believe, with Locality. I don't know what else is out there from other products that people have bought. And once you start to get to that amount of scale, how much are you really going to trust your data to this other project? And even if you are trusting it, the amount of developer resources that you have to work on it and to deploy these things and rely on other folks in the open source world, it's great. But at the same time, when I did the math, it was actually cheaper for me to buy a commercial product than it was to put developers on. And I investigated both models very heavily. It was much cheaper for me to basically buy a product that did 80% of what I already wanted than buy 6 developers and just run them into the ground for the foreseeable future.
Thank you. I wonder if 10 years from now, we'll still have the same answer, because I think of Apache Web Server, 15 years ago. IBM sold a web server, Sun sold a web server, there was 15 others on the market, and I don't know anybody that's still using those that would admit it. Sorry, that wasn't a slam against vendors. We love our vendors.
So just following on that last point, it's not just personal footprint, it's not just people and BAU costs. You've got floor space. A lot of this cheap disk commodity server thing just doesn't scale out when you start to consider the power and air conditioning and floor space footprint.
Yeah, I found it, I can't remember which of the talks this morning showed a TCO where power and operational costs were the differentiating factor. The acquisition costs, when you got big enough, didn't matter.
Right. And so I do expect that at some point in the future that some open source object store will have that sort of scale. I just don't think that we're there today. And even if you look at companies like Backblaze, they're actually doing their own roll your own internally. So obviously it makes sense for people to still do that sort of workload. What you don't hear about is that, of course, when they're building that, they're building it to solve their problems very specifically, rather than what you see necessarily in a commercial product. Or so when you see something in an open source project that gets split, someone has focus in solving a very small specific set of problems, and it doesn't necessarily scale out into the wider use case. Just like the Mars project, right? They built a very specific use case and are able to eliminate the pieces that they don't need. And that's what doesn't happen easily in a open source world, or why you see many different similar styles of project. So you might see 5 or 6 different like message queues or data stores or whatever they are. There's a reason that this MongoDB isn't the only NoSQL database out there, right? There are just too many different use cases to get to an easily simplified model where everyone is unified behind something like a Linux kernel, which is clearly just taken over the world.
And speaking to that with relation to solving specific problems, I don't see a lot of prevalence locally, particularly in the United States, of things like XRootD or any of the stuff that CERN's done with relation to EOS or anything to that effect. And it's strange because they're crowing at the top of the hills about how good it is and what they've done with it. It doesn't seem to have any mind share or interest locally. We've considered it locally for distributed file system workloads, but over here no one seems to have any interest in it whatsoever. Can anyone comment on where they see some of the bigger kind of more nascent file systems like XRootD and things like EOS locally?
I'll take a look at those. I've heard of RozoFS, ExtremeFS, a handful of others of distributed file systems. But again, when you're talking about specific use cases, it does seem to be a very complex problem of how you're solving it. And so I know today, scale out NAS, companies like Cohesity and a few other folks try to solve it that way. I couldn't speak to what those particular ones that you're referring to are, because just like you said, no mind share over here. But I'm happy to look into it and see what it is for us, because I am pretty much availability, durability, and economics driven. So if I can find a use case where it makes sense, I'll take a look and take advantage of it.
Yeah, I'd be interested to know what the national labs locally have done with relation to things like other than MAR. Did you look at things like XRoot? Did you look at some of the stuff CERN have played with over time? Because they're a very big entity in themselves. Not as big as you guys, but big.
So I'll have to admit ignorance on those. I have to punt actually to Gary because he has a better mind share of all those things, but I just don't know about them.
Okay, cool. Thanks.
Go ahead. Do you have a question? No, I'm fine. we're fine.
So you're telling me that you're going to put my tax return up onto the web?
Eventually, yes. It's 2-year-old data right now, so currently, well, it's effectively all the PII is encrypted at the application level initially, and then it's stored as a blob, and then that blob is actually separately encrypted, handled via a different key. And then we're also using AWS encryption once we get into there. So it's possible that something could happen, but I cannot tell you how much time I spend on security-driven components, making sure that it's very difficult to get to the data, along with everyone is extremely security-minded there. But yes, it will be in the cloud.
And I'm using this as just an example to start a conversation, because when it's your bricks and mortar in your data center, whether it's a colo facility behind a chain link fence or not, and somebody breaks into it and rips off a bunch of data, you're the responsible party.
That's correct. Right. It's always up to us.
And when I give you my tax return or my medical record or my this or my that, it doesn't much matter what it is. I'm just using this as an example.
Matters to me.
And you stuff it up onto Amazon, right? And somebody cracks into Amazon and steals my tax return or my medical record or something else. Now there's a finger pointing contest between, who fell apart there. Right?
No, I'll tell you that from the leadership of my company on down, there's no finger pointing. The security of our data belongs to us. The cloud is just someone else's computer. Just like you said, it doesn't matter if it's inside of our data center or if outside of our data center. It's the data that's important to us that we protect to the nth degree.
Is that going to be
in the healthcare business? It's the exact same answer. If and when we, not if, but when we start using public cloud, buck stops here. We don't get safe harbor.
And in that big long contract that I click the button on and agree when the license terms, it's going to be in there that's still your responsibility. That'd be awesome.
Don't read that either. But I can tell you that corporately and ethically that the data is protected from an end user perspective, and that Intuit considers itself the steward of that data.
Right. Fair enough. So the point is, it's an issue that we all have to deal with as an industry, that we blow off when we can because we're in a secure data center with, thumbprint encryption or whatever. It's hard, and I appreciate, and I think there maybe need to be standards that emerge that make this possible. If you'd like. I'm not giving up my microphone, though.
It's on. So I work for a bank, and the answer is we're considering things like public cloud. We're like Randy, we're not there yet, but absolutely, you're right. We own the data no matter where it is. We, as the bank, have an emerging set of regulations that are requiring us to encrypt the data at rest inside our own gun-protected databases. We have got literally guys with guns there. So the answer is yes, absolutely. It's our data no matter where it is.
Fair enough. You heard it here, everybody. The second question relates to impedance matching a POSIX file system with a backend object store. Right? Each of you have discussed different ways that we approach that, and I've been involved in projects to do this in the past as well. And I know that not every S3 interface is identical to every other S3 interface. Scality implements something a little slightly different than Amazon, than Librados does, this and that other thing, right? So there's those aspects. There's containerization aspects that, I take a bunch of small files. I have to bunch them together to make it perform. Latency, restoration if the primary file system goes down. How do I get my data back? Those challenges. So I'm curious, in each of your cases, what challenges have you faced in matching up and getting the POSIX file system to operate well and properly with the backend? I mean, it's not. I mean, granted, you got to pull in the S3 library and you got to hook it up, and it's kind of step one. But then making it work well, making it work right, is another thing. And I think that each of you has different design
constraints and requirements, I'm just maybe stimulate discussion around that concept and how we might improve the ways in which we do that, or maybe even come to some common terms about how we might represent data within the cloud that is also represented as POSIX front end. Maybe it is tar files, maybe it's not. Discuss.
That sounds like a VFS interface for S3.
Yeah, I'll just say that we do use tar. I think I mentioned that before. And we can overflow, just like we overflow tapes, right? We overflow into another object. There's no problem. As far as what we call the ultimate disaster, where you've lost all that metadata that points out to those objects, you can go read all those objects that belong to you and pull them back and tar that data back. So because the metadata about the data is in a tar file, and that's the beauty of tar.
I would say from the MARFS design standpoint, from ground up, it was designed to be fixable when things go to hell, because it will at some point go to hell. So our metadata file system we back up constantly. We don't do a marrying of POSIX to object. We bypass that entirely because we don't have the staging area that is POSIX-y that then turns into object. We go direct to object. So it's never in an inconsistent state. There's no weird edge cases where you've created this file that overflowed your disk space cache and had to decide which blocks to evict and things like that. A lot of the complexity goes out the window. And beyond that, even the objects' names, when you first write them into the file system, the name describes the original placement of the file within the metadata file systems. So you can regenerate your metadata file systems purely by having the objects around, even if you blew up all of your metadata servers. So again, we punted on that because it's too hard. It's almost impossible to do properly. So we just skip it.
So I would say with the POSIX and the object, we're definitely still learning. And one of the things we're finding, especially with these transparency connectors, is making sure that HDFS, the community really likes to hard code things. And so making sure that those connectors actually respect the HDFS API so that those already written native codes work with it. So that's one of the things with the object and POSIX that we're continuing to look into and continuing to have to pay attention to. But again, we're testing 3 of them right now. So I don't think our mind is totally made up. GPFS with the transparency, Luster with the Ham and Hal, and then Seagate's open source connector. So we'll have to wait and see how that does work out.
I've generally tried to avoid it altogether. So I typically just cheat. And if someone's using a metadata location spec inside of a database, and it's possible that they're not generally doing updates to these files, and it's sort of blob style data effectively, then I just give them a second location spec inside the database, make sure the performance keeps up to what they need, tell them they can't do upserts anymore or updates. You can only do basically just give them the semantics that they can use. So I've kept it very use case specific to basically avoid those problems because it is complex. And then I found that it's been very easy to like we've got a chargeback model, for example, right? With a chargeback model, it's pretty easy to convince people that, hey, this is going to work out for you. So that's helped. The economics have driven it a lot. But then when it comes to having true use cases for POSIX style semantics that I can't get rid of, I've just implemented other solutions that still have true POSIX semantics.
Okay, I think we're about out of time. I'd like to thank all the panelists for making themselves available and answering questions. And that's it.